How do you evaluate the double integral or iterated integral of x squared y dy dx over the region R, where the region R is the area bounded by the lines x is equal to 0, y is equal to 0, and the line x plus y is equal to 1. Hi there and welcome to the channel. My name is Ferguson Mangoma, and in this video I would like to show you how to evaluate double integrals. But first, let's get the notation right. What we have here is the function x squared y. Let's call this function f of xy. So here is our f of xy. This function has to be integrated over the region R. That's what this R stands for, with respect to dy dx. So we are integrating with respect to two variables of integration dy dx. And this whole setup here is what is called a double integral. So this is a double or iterated integral. My pen is not writing pretty. It's splashing ink all over the place, but sorry about that. I hope you can read what I'm writing here. So here is our double integral where we are integrating with respect to both dy and dx. And what we are integrating is f of xy over the region R, bounded by these lines x is 0, y is equal to 0, and x plus y is equal to 1. Now that we've got the notation right, let's deal with the process. To evaluate this integral, we need to go through the following steps. Step number 1, we need to sketch the region of integration. So 1, we're going to sketch the region of integration. We're going to sketch R. Step number 2, we are going to decide the order of integration. By this, we mean we are going to choose whether we want to integrate first with respect to y or integrate first with respect to x. Step number 3, we determine the limits. So determine limits of integration. The limits of integration. Step number 4, we set up the integral. Set up our integral. Step number 5, then we evaluate the integral. Evaluate our integral. Now let's go through these steps one at a time. Sketch the region R. Now R is bounded by x is equal to 0, y is equal to 0, and x plus y is equal to 0. Here is our x and y axis here. Is our x and y axis, x axis here, and our y axis there. Now, where is the line x is equal to 0? The line x is equal to 0 is the y axis. The line y is equal to 0 is the x axis. What about the line x plus y is equal to 1? Well, we know that when x is equal to 0, y is equal to 1. So we can put a mark here, x is equal to 1. The line passes through the point 0, 1. When y is equal to 0, x is equal to 1, meaning the line passes through the point 1, 0. So we've got another point down here. So we can sketch our curve. Let's use a ruler. It's a straight line. So here is our line x plus y is equal to 1. There it is. Let's draw it in blue. It's rather faint. So there we are. That's the line x plus y is equal to 0. Now we have sketched the region R. Let's decide the order of integration. What do we integrate with respect to first? Well, let's integrate with respect to y first. When we have decided, then we then say, okay, what are the limits of y? We draw a straight line for any given value of x. Let's choose this value of x. This line is parallel to the y-axis. So what are the I beg your pardon. What are the limits of y along this line? Well, y starts from 0 here and ends on this line where y is equal to x minus 1. Because remember, our line here is the line x plus y is equal to 1. So we can put x on the other side and we are left with y is equal to 1 minus x. So y starts from 0 up to the point 1 minus x. So we have our y is equal to 1 minus x here. So therefore, we can write the limits straight away and say 0 is less than or equal to y, which is less than or equal to 1 minus x. What about x? X starts from 0 here all the way up to 1. So 0 is less than or equal to x, which is less than or equal to 1. Remember, if we had decided to integrate with respect to x first, we were going to draw a horizontal line parallel to the x-axis where x would vary from 0 here up to a point here where x would be equal to 1 minus y. But then, of course, we chose y. So now that we've got our limits, we've got our limits of integration here, what is our next step? Our next step is to set up the integral. Now, we are integrating with respect to y first. So here is our integral. Y, the integral of y from 0 up to 1 minus x of our function here, f of x, which is x squared y with respect to y. Then we put big brackets inside, and then here out with respect to x. Then here, finally, we will integrate with respect to x from 0 up to 1. Let me just repeat what we did. Here, we are integrating first with respect to y. So we set up our integral here, which is the inside integral. Then after we have done this integration, we will then go out and integrate with respect to x. So we start from inside going outside. But remember, when we integrate, when you carry out this integration here, our x is treated as a constant. So x is held constant while we are carrying out this integration. So, okay, let's go ahead and integrate what is inside the brackets. We now have here, of course, we still have to integrate with respect to x, so it's 0 up to 1 of half x squared, because x is constant, y squared. Remember, the integral of y is half y squared. And this from 0 up to 1 minus x with respect to x. Because after we have set the limits of integration, we still have to integrate with respect to x. So let's evaluate this. It becomes from 0 up to 1 of half x squared brackets 1 minus x squared, which of course is the limit there. And this can be written as from 0 up to 1 of half x squared brackets 1 minus 2x plus x squared brackets with respect to x. I'm straying into the other side of the line there, but it's not a problem. So let's go over here. I think we got some space down here. So we can write this as, let's remove the brackets. It becomes from 0 up to 1 of half x squared, this one here, that one, this one here gives us minus x cubed. The last one gives us half x to the power 4. All this still to be integrated with respect to x. What next? Let's do the integration. That then gives us, this is a 2, remember? So it comes down here and becomes a 3. So we have 1 over 6 x cubed. Here we get a 1 over 4 x to the power 4. Here we get a plus 1 over 10 x to the power 5, because remember that becomes a 5 and it comes down here, multiplies to 2 to get a 10. So this, of course, integrated from 0 up to 1. Well, 0 gives us nothing, so that finally gives us 1 over 6 minus 1 over 4 plus 1 over 10. Common denominator, 60. So 60 here, this gives us 6 into 60, that gives us 10. 4 into 60, that gives us 15. 10 into 60, that gives us 6. Well, 10 plus 6 minus 15 is equal to 1. So the final answer is 1 over 60. Now, what we have to remember is that it doesn't make any difference which a variable of integration we integrate with respect to first. If we had chosen to integrate with respect to x, we would still have arrived at the same answer, 1 over 60. So that's double integration there for you. In our next video, we are going to do double integration with change of variable. If you are new to the channel, please do subscribe and press the like button. That's what keeps the channel going. Till we see you in the next video. Take care. Bye-bye.